Working with quadratic equations. A quadratic equation is used to represent a quadratic function. The equation is then used to build the mathematical model that will be used to develop the simulation. There are three different equations that can be used to represent a quadratic function. Each equation represents details about the quadratic function that it represents. These details provide key characteristic data. Equation number 1, the standard form. The standard form for a quadratic equation is written y equals ax squared plus bx plus c. Here is an example. Y equals x squared plus 4x plus 3. What does this equation tell us about the function? Now, we take this equation y equals x squared plus 4x plus 3. From the graph, it can be seen that the y-intercept is 3. From the equation, the value of 3 is found or matches the c value. Therefore, the value of c represents the y-intercept. Equation number 2, the vertex form. The vertex form is written as y equal bracket x minus h bracket squared plus k. Here is an example. Y equal 3 x minus 4 squared plus 5. What does this equation tell us about the function? So if we take the equation y equals 3 x minus 4 squared plus 5, from the graph it can be seen that the vertex is at 4, 5. From the equation, take the 4 from inside the bracket with the opposite sign for the x-coordinate of the vertex. From the equation, the last digit represents the y-coordinate. So from the graph, the vertex 4, 5. From the equation, the vertex 4, 5. It matches. Our graph, our equation, to find the vertex from the vertex form of the equation, take the h value for the x-coordinate, remembering the sign will change to its opposite value, and the k value for the y-coordinate. Equation number 3, the factored form. The factored form is given as y equals a to the x minus r times x minus s. Here is an example. Y equal 2 times x plus 3 times x plus 1. What does this equation tell us about the function? Now, let's look at the solution for the function y equal 2 times x plus 3 times x plus 1. By looking at the graph shown here, the first intercept is at -3. The second intercept is at -1. To find the x-intercepts from the equation, take the first bracket value and set this value to 0 and solve for x. X plus 3 is 0, so x is equal to -3. take the second bracket value and set this value to 0 and solve for x. X plus 1 is equal to 0, so x is equal to negative 1. Solution. For the equation y equal 2 bracket x plus 3 times bracket x plus 1. Our diagram matches the x-intercepts of negative 3 and negative 1 that we found by taking the values from the equation. In the equation, therefore, we could make the statement, if you're given a in the form x plus r times x plus s, the value of the x-intercepts would be x plus r is equal to 0, x is negative r, x plus s is equal to 0, so s is equal to negative s. How can you tell if the graph opens up or down? Here is the equation for the graph displayed on the right. Y equal 2 bracket x plus 3 bracket x plus 1. The graph opens up. We can see that from the diagram. But look closely. The sign in front of the a value, which is 2, is positive. Now, look at this example. Here is the equation for the graph displayed. Y equal negative 2 bracket x plus 3 bracket x plus 1. The graph opens down. If we look closely, we see the sign in front of the a value 2 is negative. Ah, a clue. Here is the rule to follow. Positive a, the graph opens up, as shown. Negative a, the graph opens down. Improve your game. Learn quadratics.